Hello friends, today we are going to learn a new concept from your last chapter, that is a cycloconverter. Okay, so many times in exam you will be asked these questions to describe a cycloconverter with its diagram and waveform. So first of all, let's see what is cycloconverter. A cycloconverter is a circuit which converts input power at one frequency to the output power at a different frequency with one stage conversion. Okay, it is AC to AC converter, and it will convert input power of one frequency to the output power with another frequency. If it is increasing the frequency at output side, then it is called as a step up cycloconverter. If it is decreasing, see here, if frequency is increasing at output, is it is step up cycle converter. If frequency is decreasing, then it's called as a step down cycle converter. Okay, there are a few more types, like if depending upon the converter used for conversion, it can be classified as a 2 pulse cycle converter, 3 pulse cycle converter, or 6 pulse cycle converter. Or else depending upon the input and output phases, means whether it is single phase to single phase, then it is called as single phase to single phase cycloconverter. If it is converting three phase to single phase, it is possible, it is called as a three phase to single phase cycloconverter, or three phase to three phase cycloconverter. Okay, these are few more types, but in your syllabus we are dealing with only step up and step down cycloconverter. Okay, so what are the different uses of a cycloconverter? So mostly the application at present application of converter include a speed control of a high power AC drives. Then it is used in the induction heating. Then it is used in a static wear compensation. Then it is used for converting variable speed alternator voltage to constant frequency output voltage for use as a power supply in aircrafts or chipboards. Okay, so these are some applications of a cycle converter. Okay, so here you can see a diagram of a cycle converter. It is a single phase to single phase cycle converter circuit. One, this is a midpoint type circuit. This is a bridge type circuit. Okay, in exam it has been asked. Mostly you go for this midpoint type because it is simple, and I'm going to explain you this. Even though you some want to draw this diagram and explain it, is also very easy. No problem. You can explain it also. Okay, so we'll start with the this midpoint type cycle. Now, how it operates? You can see there is a single phase voltage source, then the center tap transformer arrangement, and there are four devices. Okay, so P1 and P2 will conduct for a positive half cycle, N1 and N2 will conduct for a negative half cycle. Okay, so let's first of all let's see its step up operation, means how frequencies increase. Here you can see the input frequency is like this. See, this is the wave. So this is one cycle. See here, 1 upon Fs, T is equal to 1 upon Fs, or Fs is equal to 1 by T. This is the one cycle. From here it will start. This is one cycle. But by using cycloconverter, we have made several cycles like this. These are the cycles. Okay, right? So frequency stepped up around 1, 2, 3, 4, 5, 5, 6 times. Okay, let's see how it is. Okay, how it works. Now, see here. During positive half cycle, terminal A is positive with respect to terminal P, right? Therefore, at positive half cycle, SCR P1 and N2, these two SCRs are forward bias. Try to understand properly, because A is positive with respect to B. So, you can see P1 is a forward bias, or from here, like this, N2 is a forward bias. Okay, P1 and N2 are a forward bias. Okay, now at omega t equal to 0, yes, see, omega t equal to 0 at this point, okay, your SCR P1 is forward bias, okay. So at omega t equal to 0, SCR P1 is turned on. Now you can see load voltage is in this way, means like shown in diagram, positive. This is positive, this is negative, zero. So see, load voltage is a positive here, increasing gradually, right? Now this is the condition. Now At instant omega t equal to 1, at this instant particular omega t equal to 1, till then P1 was conducting like this. At omega t equal to 1, P1 is force commutated, means made forced off, and P2 is made on. P1, P2 are positive. P2 is made on. So what will happen? Now it will see here. I'm sorry. P1 was conducting. Now N2. P1 and N2 are forward bias. As I said, when A is positive with respect to B, like this, P1 or like this N2. P1 and N2 are forward bias. So previously P1 was conducting from here like this through P1, and current direction was like shown in the diagram. This was positive, this was negative. Now N2 is conducting. So what will happen? This will be positive and current will be reversed, voltage will be reversed, and through N2 it will complete path. Are you getting? It is like this. So what happens? Voltage polarity is reversed, though current polarity also. Voltage polarity is reversed till omega T2. Now at omega T2, again N2 is force commutated and again P1 is made on. So again voltage polarity will be reversed now. This side will be positive, this side will be negative. Okay, till omega T equal to 3, P1 is conducting. At omega T equal to 3, P1 is force commutated, again N2 is made on. So previously this side was positive, this side was negative. Now as N2 is made on, it will conduct like this. So this side will become positive and this side will become negative. Means reverse. When N2 is conducted like this. Again P1 is made on, again N2 is made on. Likewise, in one positive half cycle, we have made in a half, I will say, in a half cycle, we have made around 1, 2, 3, 4, 5, 6 cycles. Okay, 6 not cycles. So if you count cycles, then 1, 2, and 3 cycles we have made. Okay, now after this point, what we have done, input wave is reverse bias. Reverse now. Sorry, reverse bias not reverse. Means now terminal B is positive with respect to A. So now what will happen? See, P2 and N1 are forward bias. P2 and N1 are forward bias. So initially P2 is forward bias. So it is conducting like this. See. So this terminal is a positive with respect to this terminal. Okay, and negative side. So P2 is conducting like this. Initially P2 is conducting. So right side is a positive with respect to left side. Means positive side. Till here. At this point, N1, P2 and N1, no? So N1 is made positive, P2 is force commutated. So what will happen? Now it will conduct like this. So the terminal which was positive previously will become negative, and terminal which was negative previously will become positive. Means reverse side like this. Again P2 is positive. Again N1 is positive. N1 sorry, P2 is conducting, N1 is conducting. Again P2 is conducting, N1 is conducting. So this is how we can increase the frequency. Are you getting? So we can see that the low frequency of the expected frequency af0 is nothing but 1 upon t2 minus t1. Okay, t2 minus t1 means, or omega t2 minus omega t1. Okay, this is the 1 upon time period. This is time period. If this time period is increase, difference between these two is increase, then obviously frequency will decrease. When difference between these two cycles means omega t2 minus omega t1, when this difference is decrease, obviously frequency will increase. So I can say frequency f0 is nothing but 1 upon omega t2 minus t1, or 1 upon t0, otherwise I can say 1 upon t0. Okay, so we can see the frequency is increased over it. So previous time cycle was this much, this was the time cycle complete, and now new time cycle is only this much. Are you getting? So 1 2 3 4 5 6. Okay, 6 cycles are there in one cycle. Frequency is increased in a step of 6. So what is the step up cycle converter? Okay, now step down. Step down with discontinuous. Okay, now what is step down discontinuous current cycle converter? When A is positive with respect to 0, this is the cycle. Okay, when B is positive with respect to 0, this is the cycle. Are you getting? Don't get confused. When A is positive with respect to 0, then this is cycle. when